Okay. Hi, everybody. Good morning and welcome to the first session of the day. Today, we're going to talk about students' mathematical reasoning with and about representations. And our presenter today is Wesley Martsching from the University of Northern Colorado. If you have any questions for the presenter during the session, please feel free to enter those into the chat at the bottom of the Zoom room screen. We will address them at the end of the talk. And on that note, I will hand it over to Wesley.
Okay. Thank you. Good morning. Thank you all for joining. I will be talking about my study that looked at students' mathematical reasoning with and about representations in undergraduate mathematics. So in the mathematics education literature, representations can be external to the individual. So our gestures, what we say, what we write. They can be internal. So our internal representations, our cognitive constructs. They can be more conventional, so graphs and tables that we're all accustomed to using, or they can be more idiosyncratic, so created by an individual for the moment that they're interacting with. I will be primarily focusing on external representations and more or less toward the idiosyncratic side as well. In the literature, representation research has often focused on specific content areas like algebra, calculus, and it's also focused heavily on specific representations. So algebraic functions, graphs, tables. And two of the studies particularly that influenced my current work was Stylianu's research, which looked at representations as tools in problem solving. Stylianu determined that expert mathematicians and middle school students used representations as a means to understand information, as recording tools, as tools facilitating exploration, and as monitoring or evaluating devices. The other study that really influenced my work was DeSessa's study from 1991, which looked at students' reinvention of the graphing representation. Motivation for the present study, representation is heavily emphasized throughout the standards documents. And for me right now, the CUPM guide is really the main one that influenced my work. And also my observations as a teacher and a researcher influenced this. So I've noticed that my students and my participants in the studies will often create multiple representations for the same context, but the meaning for each representation might vary. So my research questions were, what representations do students use when engaging in mathematical reasoning and problem solving? What conceptions do they have when reasoning about a task using these different representations? And what meanings do these representations actually have for these students? I sampled my population from college algebra and calculus 1 courses because of the diversity of student backgrounds and their interests, and because instruction in these courses are really centered around more conventional representations a lot of the time. However, because this study occurred at the start of the COVID pandemic, I was only able to conduct interviews with 2 participants, Ceres and Samantha, before we went fully online. And both of these students were enrolled in Calculus 1 at the time of this study. Each student participated in a one-on-one task-based clinical interview that lasted about 75 minutes. I collected data using over-the-shoulder camera and iPad screen recording, and then I used an additional audio recording device just in case there were any issues with the audio from the camera. The study was comprised of 2 tasks. The first one was this task that depicted this car traveling from Fort Collins around Loveland to Greeley. I only realized kind of when I was creating this presentation that my participant decided to use the same pseudonym as the individual that I had put in this task. So when I refer to this task, I will refer to the car instead of Samantha. But this was the first task, and since both participants were from the Rocky Mountain region, they are kind of familiar with the orientation of these cities. They weren't given this map, but it was kind of taken that they knew or were familiar with the area. This task was modeled after several tasks that have been looked at in covariational reasoning literature because it really often challenges students' notions of conventional representations, especially graphical ones. Their graphical representations often challenge what they think a function should look like graphically. And so this was really meant to facilitate the use of more idiosyncratic representations. The second task was just a standard compound interest task. I've used it before in my own research, and this is one of those tasks where I've noticed that students will create different representations for it, but the way they talk about the context through these different representations will vary. And so with these two participants, I did change the question order for this second task. One question had the participants discussing aloud how the account value is changing over time. The other one had them graph it or model it through graphing. And I did change this task order because I wanted to see how their reasoning changed when the order changed. For my data analysis, I took the audio, the screen recording videos, and over-the-shoulder videos, and I superimposed them so that I could look at the verbal, gestural, and written representations at the same time. I used Otter AI to transcribe the audio data, and then I went back through and corrected them myself to make sure that everything was okay. And then I rewatched all the videos and reviewed the transcripts to familiarize myself with the data before coding. I used inductive analysis to look for emergent themes in the transcriptions, videos, and artifacts. And in particular, I focused first on what type of, the representation that was a focus in a moment, what the meanings the participant had of this representation was, and how the representation was being used in that moment. And I do want to highlight that this is different from the work that Stilianu did, because here, the representations are often the product or solution to a problem and are not just tools being used to mediate the problem-solving process. The three themes that came out of my data analysis were representations as direct interpretations, which is where these students would create a representation to exactly model what it is that they were perceiving. Representation as constraints, which could be used to constrain the student's reasoning or constrain the interpretation of another representation that they'd already created. And representation as auxiliary objects. So sometimes the initial representation that a participant created did not convey all the information they wanted it to, so they might create a secondary or tertiary representation that could add additional information to their original representation. So I'll go through some examples of each of these themes. The first one has Series responding to the first task, which said create a representation that you could use to convey the car's trip from Fort Collins to Greeley to someone else. And Series said, I basically just drew out the basic elements that I know. He drew these vectors that depicted the car's trip from Fort Collins around Loveland to Greeley. Next to each of these vectors, he wrote out how fast the car was traveling, how long it was traveling for, and then out to the left and below, he illustrated the distance between each of the cities. Similarly, Samantha created this map that also depicted the orientation of the towns and showed the speed and duration of each leg of the journey as well. For the compound interest task, Series was asked to reason verbally about the task before creating the graph, and Series immediately jumped to this kind of step value depiction. He said, the amount is going to stay at that stagnant value. You're going to see it jump, and you're going to kind of see the step pattern. It doesn't go through these range of values in between, it just kind of jumps up. And so for Series, reasoning about this task aloud and then creating it on the graph meant that he wasn't relying on any algebraic formulas or anything else to create his graph. He just drew it strictly from his interpretation after reasoning about it verbally. Looking at representations as constraints, again, going back to series first, he kind of took that original depiction of the car's travel and situated it within this triangle. So because Loveland is basically due south of Fort Collins and Greeley is due east of Loveland, he said that if at any point in time the car travels outside of this triangle, it means that either he did something wrong or it meant something was wrong about the context to begin with. So it kind of constrained his reasoning and was used as a way to check what he was doing. Samantha also continually referred to her map and also used this reasoning about the orientation of the cities to talk about what she was doing. And in this example, this third question for task 1, the participants were asked to create a representation showing how the car's distance from Loveland changed over time. For Samantha, her interpretation of this task also provided a constraint. For Samantha, she couldn't talk about how the car's distance from Loveland changed over time because the car was never in Loveland. So we see this additional constraint where Samantha said, well, this question is nonsense because her original representation clearly showed that the car was never in Loveland. We can't talk about that relationship. And on the compound interest task, Samantha engaged in the task first before being asked to reason verbally about it. So she created this algebraic representation that you see in the top right, checked it using a couple values in a table, said, okay, this is the function. Now I'm going to graph it. And she created this smooth trace. When she was asked to reason about it verbally, she, similarly to series, started talking about this step-like pattern, which you can see that she started to draw in blue. But she said, well, that doesn't really line up with the representation that I already drew. So it can't be this step-like pattern. She actually concluded that the original context must be wrong because the amount in the account has to be growing continuously to match her graph. And finally, looking at representations as auxiliary objects. For this question, the participants were asked to create a representation showing how the car's distance from Fort Collins changes over time. Series said, well, I drew the trip in 2 dimensions. I can put that on an XY axis and I can show what's happening that way. But he said, this doesn't really have any value of time that we can see. So I'll create this other representation, this time series, where I can talk about these discrete sets of points along the trip, and I can talk about what the vertical and horizontal distance traveled actually is. On a later question, which had the participants represent how the distance from Fort Collins and the distance from Loveland relate, series color-coded 2 distinct vectors. The blue vector that you see actually represents how far the car is away from Fort Collins at any discrete point. And the red vector represents, or the red segment, represents how far the car is away from Loveland at the same points in time. So again, that coordination of the 2 values simultaneously. And in this case, he used these additional red and blue vectors to show how that distance was changing from both cities. I do see connections between these three themes and other things in the literature, especially Stilianu's research. So the representation as a constraint really kind of resonates with that representation as a tool for monitoring and evaluating. But again, I do want to highlight that in that research, the representations were a tool in problem solving, and here the representations are the products or the solutions themselves. There are also, again, those connections to meta-representational competence. So looking at how students can judge their own representations, how they can critique them, and how they can create them. There were quite a few limitations. Obviously, I would have loved to have had more time with each participant, maybe 2 interviews. Technology was sometimes an issue especially with the screen recordings. It seemed like my iPad was recording in discrete intervals as well. There were only 2 tasks and 2 participants. I would love for those numbers to be higher as well. And I only interviewed 1 participant at a time. So I do believe that future research should continue to look at representations in this way. And in particular, I think it should look at how different idiosyncratic representations and how these differences in held meanings impact student collaboration and sense making in group work. So thank you all for attending. There's my contact information if you would like to reach out.
Thank you, Wesley. Does anyone have any questions for him?
I have a question. This is sort of asked from a position of ignorance as someone who doesn't do education research. What's the benefit of the overhead camera? So I feel like when you showed us a picture of their work, I got a really good understanding of what they did. What more do you get from it, seeing it sort of play out in time?
So being able to see the screen recording play out in time shows us, what they are creating at any point in time, what representation they're talking about. The over-the-shoulder camera also shows us what kind of gestures they're making. So that didn't come up a lot in this research, but if they had have been making these very particular gestures, that could also be considered an external representation. So that's just something I tend to do in my research, is using that over-the-shoulder camera.
That's cool. Also, that was interesting stuff. I hope you keep doing more of it.
Thank you.
I think it's going somewhere.
Yeah, I love it. It's great. It's interesting. I love seeing it and working with the students. Other questions?
Hi, Wesley. That was a really interesting. I was wondering, what overall students' interactions and representations look like over the semester, and how that relates to how they use them in this kind of tasks. I was just curious. I know that's not part of your research, but I was just wondering overall how their experiences impact their reasoning and engagement with representations.
So I think that would also be a great follow-up question for this study. I was not the instructor of record for that Calc 1 course, so I actually don't know what kind of content they covered, especially right before these interviews. That is something that I myself wondered about, especially in seeing like series' time series, but I don't have access to that information.
All right, thank you.
Okay, it looks like we're about out of time. If you have more questions, you can email Wesley for them. But thank you for all that great information that you shared with us. I've posted in the chat where the next meetings are. The next session will begin in 5 minutes, and you can see in the chat where those are. You can also go to the conference website for a complete list of sessions and their descriptions. And while accessing the conference website, don't forget to swing by the virtual booth to say hello to the Hawks team. You can view a quick demonstration and be entered to win a $50 Amazon gift card. So we will see you all at your next session.